Yesterday we saw TCP again, and then we built our own HTTP server from scratch. That was really painful, so then we got introduced to the net HTTP package, which makes it all a lot easier. So, how do we make an HTTP server? So somebody in Scratch show me how we do that. So
Scratch, you gotta start scratch.
So what do we do in here?
You're gonna need the net package and listen and serve.
Okay.
And then the first argument is the port,
Yeah.
and the second one is a handler.
Yeah. So it has to implement what interface?
The handler interface.
That's right. What happens if I pass no in it?
Then it uses default ServeMux.
Exactly, it uses HTTP.default ServeMux, which is a handler. So what is a ServeMux?
It's a multiplexer.
Yeah, exactly. What does that mean?
It means that it plexes many times. Well, multiplexers, like I looked that up, and it's like an electrical engineering thing.
Yeah.
It has something to do with like routing, like, you know, different pathways for electricity or something. I don't know.
So, I mean, what does it do for us though?
Oh, what's it do for us?
What's the purpose of the ServeMux?
Handle different interfaces.
Based on the URL, it routes traffic to different handlers. So it multiplexes handlers by it. So if I go, if I make a ServeMux, but we'll just use the default one, and remember I can say http.handle and give it a path. So if I said /dogs, and anything that started with /dog/ would go to this handler that I gave it. Okay. Does anybody remember the parameters that the handler function takes? What's the first parameter? First argument.
Piece of the address.
The response.
The response, right? And that's an interface, so it doesn't have a star. And then the second one is the request. And that's a struct, so it does have a star. And then it doesn't return anything. The reason it doesn't return anything is because, how do we write to the response? If I want to write dog to the response, how do I do that?
Use something that takes the writer interface, like format fprint or io.writer.
Yeah, so you'd say dog. And that would take the string and send it to the response, and print it out. How do I set a header on a response?
It's
Like suppose I want to change the content type.
Response dot header method. That will give you a map-like object.
Yeah.
It is a map, but it's got some additional methods.
So we use .set. So we'd say content type. Text. I think yesterday said plain text. It's text plain. And that would make it plain text. So why do we use set and not? So we could, since it's a map, we could say res.header content type equal. Okay, so that's basically equivalent. Why do we use set though? Instead of that.
Shorter.
But it is shorter because this is a little cumbersome having to make a slice because it can have multiple values, so it takes a slice of string instead of one string. The other reason is that there is sort of a canonical way of representing these, and it does that bit for you. It doesn't matter so much on the set. It does matter on the get though, because if the case were different, remember maps are case sensitive, and your browser is allowed to send this in a different case. So you could be all lowercase, for example. And I think the spec says that's fine. But if we use the map like this, if I did a get instead of a set, so I said rec.header and then brackets, and they send it through as If they sent this through as all lowercase, I wouldn't get it. I wouldn't be able to read it. So get handles that for us. So instead of using the brackets for the header, you should do .get. That's all I'm saying. Whoops. But otherwise, it's a map. It's doing the same thing. All they've done is made some helper methods to make it a little easier to work. So that's how we do headers. How do I get the URL?
It's request.url.branch or something.
Yeah, so if we looked at URL, you can see there's a bunch of stuff. Let's just look for URL here. It's just net URL. So it returns this thing. That's a struct, so it has all these fields. And these fields are the broken up pieces of a URL. Okay? The reason they do that is because you often need to use only a part. For example, our routing doesn't generally use the query. We'll look at more what this means today. It uses the path. So I have my path, question mark, some stuff. I generally don't care what the question mark part of that is. For routing, I use the path. And so that's why they've done this, is that you can get to it really easy this way. Right? I can say rec.url.path just to get to the path part of the URL. And that's this part of the URL. Or the host part, or the user info, or the scheme. Pretty rare to need the scheme, because generally, what's the scheme? HTTP or HTTPS. So it's rarely anything else, so you really don't need to worry about that. But we use the path a lot, and we'll see the query, better way of doing the query today. But if I want the whole URL, I can use, instead of rec.url, request URI, and that returns the thing as the user sent it in. So unparse just the raw, if I wanted to see the whole URL. Okay, so that's basically how we work with request response. Generally, we might set some headers and we just write to the response data. What if I want to send a file?
You gotta open the file and read it, old school way, like ours are.
Yeah, but we don't want to do that.
If you just want to send a file.
We just want to send a file, a named file on our hard drive. We want to send to the response.
File server.
Yeah, serve file. Takes res, rec, and a name. Whatever. Where does this file come from?
System directory.
So it's always relative to the working directory. When I don't, if it starts with a slash, then it's an absolute directory. But if it starts like this, it's going to look in the folder that's running the program. So where it's running right now, it's going to look for the folder, the name folder, the of, and so on for that image. Okay, so it's always relative to the working directory of the program. That's important because sometimes people think it's relative to this file. It is not relative to this file. It's relative to where you started the program. Because we're doing go install often. And so when you do go install, it places the executable in the bin folder. So you could run that executable from any folder. Okay? That means that unless you bring along the folders associated with it, you're not going to be able to serve those files. Those files aren't put into your binary. They're sitting as files on the hard drive. So they need to be there for you to be able to run your server. Okay?
So you have to run your binary from your root.
You need to run the binary from the folder that contains the assets that you want to serve via server file.
So if you have a file, you have to put it in the same folder.
Yeah, I mean, so we saw in that example we were using an assets folder. It just means if I want to run the binary from somewhere else, I need to copy that assets folder with it. Okay? Because otherwise I won't be able to find those files. Because they're just files on the disk, so it's all relative like that. That does mean that sometimes people want to be able to package all the files together. I don't want to get too far into the weeds on that, but we can search for go bin data. And there is a wonderful package, this package, which generates Go code from any file. What it does, you hand it a file, and it creates a giant byte slice of that file, puts it in your Go code, and now it's as if you've embedded the file inside of your Go program. So people often use that. So maybe we can see the example.
What's that package called?
Go bin data.
Bin data.
So let me go get it. And
Primarily for speed, Caleb? Is that why you do it?
it just makes it easier to deploy a program
Oh, okay, so it's all packaged.
because everything's all together. So if I go to our day 2 HTTP example 2, yeah, this is where we have our assets folder. So if I go to the docs, it says you can say the simplest invocation generates a bin data.go file, and the current working directory includes all the assets. So if I say go-bin data and then give it my assets folder, okay, so it didn't print anything, but if we look inside the folder, we now have this bin data.go. So let's look at that file. This is really funny. So code generated by go bin data, it went and got this image and dropped it in here as a big, huge byte slice. This goes on for a while, so let me turn on software. Yeah, the whole image is sitting in there. Isn't that funny? Images could be pretty big. So that gives you a sense of perspective about the difference between a text file and an image. Images are much larger than text files. So it just keeps going and going and going. But it's just a big byte slice, right? And so what he's done is made these helper functions that he generates. So he's generating Go code, and then you can use them to serve files. So if we wanted to do that, he has an example of how you use it in your code. You do it like this. That would get you the data. And then I could use the IO copy to send the data. Okay. But I just prefer files. They're better because it's just better to use a file in general, just because it's way simpler. Like this is, I mean, do you really want to have this bin data Go file in your source code? You can't. That's the point. But I'd rather just keep it as a folder and just remember that when I need to like deploy this application or whatever, include that folder and you're good to go. But we'll see more about that later. Okay, so that's serving files. And that's mostly what we covered. I want to reinforce this TCP thing. So what I'm going to show you now is we'll go back to HTTP, listen and serve, and we're going to walk through this function. Part of learning how to write software is learning how to read code. That's a huge part of software development. And so it's a good practice to try and sometimes just dive into these functions. So let's look at listen and serve. And you can see that it creates the server and then calls listen and serve on the server. So we need to find this guy. Whoops. So I'm going to look for listen and server. So here it is.
Old Depeche Mode song.
I don't know. So here's listen and serve for the server. So that's what it calls this. Okay, so that it's the address. Interesting that it supports this. So instead of :9000, if you had just put an empty string, it would have done :HTTP.
Yeah.
That's very interesting. Does anybody know what that's going to end up being? 80. That's the default port for HTTP. So you can do that instead of 80 and say HTTP.
Browsers interpret that correctly.
The Go library does it for you. Your browser, if you leave it out, so there's no port Golang.org : there's no colon there. If you leave it out, then it does 80. Or in this case, since it's HTTPS, it does 443. So for secure, it's 443. For insecure, without the S, without the lock icon, it's 80. That's its default. Okay, so it creates that, and then look at that. Doesn't that look familiar? Right? It creates a TCP listener, and then it calls serve. So this guy is defined right here. See, this is going to look very familiar, right? It makes a for loop. Look, it's deferring the listener close. We'll see in a second the delay here, but it does a for loop, accepts the connection. Okay, let's ignore the error bit handling here. Though there's something interesting there that I want to talk about. And then it calls new con here, right? And then look at that, right? This is exactly the same way we were writing our code. So what it's doing behind the scenes is exactly how we would do it. Okay. Now it has a lot of other stuff to handle all the cases and things, but the basic structure is very similar to how we built our, manual server. So I just wanted to show that this is really just a TCP server underneath with the for loops and the parsing of requests and all that. So the interesting thing here is that errors are not necessarily indicating that the program has failed. They can be, like if you try to do something too many times, your operating system might be like, you're not supposed to do that or whatever, and then you can retry. So very common to have errors that are not permanent errors, they're temporary errors. And the net error interface, so if we go look at that, has a temporary method, which will indicate if this is true, then it was a temporary error. If it's false, then it's like that's like, oh, I couldn't bind to the port. That would not be a temporary error. That's like a real error that you can't really recover from like that. And so sometimes we have errors that are temporary. So what this is, does anybody remember what this means? E dot and then in parentheses, net dot error. What that's doing?
That calls the error. Isn't there a default like string kind of error function thing?
We're not invoking a method here.
It gets the specific implementation of the interface.
Yeah, so remember that if I were invoking a method, the parentheses would be here.
Okay.
But I've wrapped that in parentheses. This is a cast. And actually this is what's called a type assertion. So I'm asking, is E a net error? If it is, then OK will be true. If it's not, then OK will be false. So what we've done is we got an error. All we know is that it has this method, which returns a string. That's all we know about it, because that's all error is. That's all the error interface defines, is that it has this method, a string. But we know that it's probably, since we got this from accept, probably it's not just an error, it's probably a net error, because that's what the net package tends to return, are net errors. So what we do is we say, is this a net error? That's this type assertion. If it is, so OK is true, so it is a net error, then I can call this method. Because now I know that it's a net error, and I know that net errors have this extra method called temporary to indicate whether or not they're a temporary error. Okay? And then, can anybody describe what this bit's doing here? So now I know I have a temporary error, and the idea is that I want to retry. Okay? So I want to try again. So what does this bit of code do?
Tries again.
Right. So here's our try again. Right? That takes us back up to the forward. So we're going to see the continue. When we get back up here, I'll accept again. So there's our retry. This is a sleep, right? So this is implementing an algorithm called exponential backoff. Right? So the idea is that I start with a small delay, then if I get another error, I increase the delay a little, and increase it again, and increase it again, like times 2. And that's a pattern for handling errors that involve this temporary condition kind of thing. In other words, say I'm trying to connect to a website. And you actually will see this algorithm implemented in Gmail. They implement the same algorithm. And I don't have an internet connection. And so what it'll say is retry in 0 seconds, and then immediately retries. And then it says retry in 1 second, and then retry in 2 seconds, and then retry in 4 seconds. And it keeps increasing the amount it's going to retry by. Okay? And that's a general pattern when you have errors like that are temporary. You expect them to recover, but you're not sure how long it might take. We'll just try it for a short, and longer. Okay? Until you hit some max, and they've set a max here for how long, maybe it's a minute or something. But that's the general approach, is to use an exponential backoff algorithm. Okay? So I just wanted to show you that But otherwise, this is very much like the code we wrote.
And it resets the delay there, doesn't it?
I think it resets it somewhere.
After the if, I think.
Here, it resets it here. So if it succeeds, it goes back to 0. But
Where's the temporary function come from?
that's defined in net.
Okay.
That's the interface over here.
All right.
So it said, is this a net error? It is a net error, therefore I can use this method.
Okay.
And so that's a temporary error, and that's what so it represents a network error. That's a more specialized version of error. But notice it includes, in the interface here, embedded in the interface is error. That means that error is an error, right? Remember the is-o relationship? That's the same idea. So like I said, if you ever have that problem, this is a good algorithm to use for errors. In particular, there's a lot of cases where this is, they'll do another step here, which is they'll make it a little more random. And can anybody guess why they might do that? So in other words, instead of just always retrying 1 second, then 2 seconds, then 4 seconds, you might retry 1 second plus anywhere from 0 to half a second. So you give a sort of random amount of time in there. Okay, so let me give you an example. So on Ethernet, when you have two computers connected, so you have one wire that involves like actually transmitting information over that wire. And the two sides could send data at the same time. And they'll collide, okay? So if everybody used the same algorithm, it would retry it the same second and collide again, and then retry it 2 seconds and collide again, and then retry it 4 seconds and collide again. So if you add a little bit of randomness to it, the chances of them colliding again are very small, right? Because this guy waited 1 second, this guy waited 0.75 seconds. And so now they don't collide, okay? And so sometimes you'll see that. They'll add that little bit of randomness just to make it unlikely that you'll have those collisions. In this case, it doesn't matter. But like I said, you'll see that in Gmail if you ever disconnect from your internet. Gmail will start, you'll just show it on the bar at the top. It'll start saying reconnecting and then reconnecting longer. You can see that. Okay. So we can see that these are just TCP servers underneath. And like I said, this is definitely worth reading because you find things like that. Like that's a gem that you can learn and use in your own code. And there's lots of that stuff going on in here. So it's definitely worth reading through code to try and understand how it works. And that will make you a better programmer. Okay. Any questions about any of that? Okay, so the plan for today is we're going to cover a few more things about HTTP. And then we're going to spend the last half of the day working on a small project. We will be creating a photo blog. So we're going to build a whole website. That's the plan. Okay. But first, we'll go through a few more HTTP things which will help us build it. Okay?